Hello, this is Mr. Greco, and welcome to my video podcast on mass, volume, and density. Let's get started. Mass, as you probably remember, is the amount of matter or stuff in an object. It's measured in grams. We'll take a look at this and always remember the amount of stuff. Volume, on the other hand, is the measurement of the amount of space an object takes up. We're going to be measuring volume in milliliters for liquids or cubic centimeters as the example below shows. You can measure the height, length, and width in centimeters, and you get centimeter times centimeter is cubic centimeter. Now let's take a look at an application of mass and volume. What do you think would have the greater volume or the greater mass, and why? A kilogram of feathers or a kilogram of rocks? Well, let's take a look. Which would have the greater volume? Which would take up more space? Which has less stuff? The greater mass, which would have more stuff in a certain volume? Well, if you look at the feathers, you know a little bit about the feathers. They would probably have a greater volume because they are so light and they would take up more space to have 1 kilogram, whereas a rock is very tightly packed and it has less space to have 1 kilogram. That was what we call density. Density is defined as mass per unit volume. You can see it's how tightly packed and how heavy the molecules are in an object. It's the amount of matter actually within a certain volume. In my two examples here, you can see we have a cube outlined here in the same volume, but on the left there's much more matter packed in that volume, so that would have a higher density. Let's take a look at some other demonstrations. We're going to do people in a square in the class, or else we've already done it, you've seen it. How about this? Which square is more dense? We'll take a look and look at which square has more stuff per given volume. It would easily see that the one on the right is more tightly packed. What about this example? Which one is more dense? Well, now we've changed the volume. On the left, we've decreased the volume. So we have the same amount of stuff in less volume, makes it more tightly packed, therefore it is more dense. How can you actually calculate density? Well, it turns out there's a formula on the Earth Science Reference Table for density. We'll take a look at that. You need to find the mass. You need to find the volume. We already mentioned there's two ways to find the volume. You could use centimeter times centimeter times centimeter for a solid regular object, or you can use the water displacement method for an irregular object. This is outlined here on the right. Then you can just look at the equation on the reference table. Density is mass, grams, divided by volume, milliliters, and therefore we have mass per volume, D equals M over V, or grams per cubic centimeters. Don't forget your units. So here's an example. We're going to look at the mass of a we're going to try to find the density of an object that is 35 grams and it takes up 7 cubic centimeters. So we set up the density problem. We write down what's given. You can see on the left there we have mass 35 grams, volume 7 cubic centimeters. Our unknown is D, density. So we're going to go ahead now and look at the equation on the reference table. D equals M over V. We're going to plug it in here and divide. And then you can see that 35 divided by 7 is 5 grams per cubic centimeters. Notice the units come right out perfectly if you leave them in the equation, grams per cubic centimeters. How can you change the density? Well, we're going to have to change the mass and keep the volume the same. So let's say if we increase the mass, we increase the density. If we decrease the mass, we decrease the density. So which container is more dense? We'll take a look at letter A. You can see we have the same volume as B, but there's less stuff, less mass. So therefore, it would be less dense. Or if you look at it, you can see it's less tightly packed. Same thing. How about now? Let's change the volume. Keep the mass the same. On our containers here now, you can see that container B is less volume. However, we have the same number of M&Ms, 4 in each. So therefore, letter B, it has this more tightly packed because it has been in a smaller volume. So therefore B would have a greater density. In your notebook you can take a look and write down, if you'd like, what 2 ways can increase the density. So we have 4 M&Ms in this container and we're going to try to increase the density. So one way is to actually just keep the same mass and decrease the volume, making this more tightly packed, which would increase the density. Or we could actually keep the same volume and add more mass, more M&Ms. Now they are also more tightly packed, and therefore the density goes up again. There's also a factor of liquid density. Here we have water, oil, and a superball. Can you tell which one is more dense, which one is less dense? If you take a look at the object that's on top, it is less dense. And here you can look at a sample on the right here, or with many objects, it's still the same rule. The less dense substance will always be on the top. So the most common one in the glass there is liquid and is water and oil. You've probably seen that oil will float on water, making you see that oil is less dense. Now we have some really colorful layers here, and you can try it on your own. So I'm going to give you the actual densities. There's 15, 10, 9, 12, 3, and 7 grams per cubic centimeters. And if you could actually put them in order, so you can match the colors to the correct density. So I'll give you a second here to look it over. And you're thinking probably, hopefully in your mind, that the object on the top, the green one, should have the lowest density, and the one on the bottom, the brownish one, should have the highest density. Let's see if you're right. 3, 7, 9, 10, 12, and 15. Sure enough, that's how it works. So don't forget, when you're reviewing, you can review density, and you can look at the formula, you can look at liquids, and you can also look at we're going to be looking at graphs of density. For right now, we'll end the podcast. Have any questions, please bring them up in class.